Hey guys, this is Mrs. Tran-bloom. I am starting you guys with 2.5 parent functions and basic features. It says here, first semester parent functions all have several features in common. Let's explore to figure them out. So the first parent function that we are studying is the linear function. So it is y equals x, and sometimes we write f of x. So f of x is the same thing, oops, I need a pen. So f of x is the same thing as y, okay? And normally we use f of x to denote that it is a function. Well, let's fill out some of the key information in the box. Actually, you know what? Let's graph it out, okay? So when you have a linear function, we can make a chart if you like. Okay, there are two ways to graph a linear function. You can make a chart. Usually, I get, oops, 0 does not have a negative, I lied, 1 and 2. Normally I get 5 values because the more values I have, the straighter my line is. Or you can also start with the Y-intercept because it is the parent function. The Y-intercept is 0, so think of it as y equals mx plus b, except that in this case, your slope is 1x and your b is 0, just like that. So we can start at 0. We can go up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. And you can do a few of these. Let me see if I can get a ruler out here so I can. So I guess I used to have a ruler on this app, but it's not here anymore. So I will just graph this out by hand. Let me go find my pen. Okay. Okay, as best as I can of a straight line. So the x-intercept will be 0, 0. The y-intercept happens to be at exactly the same spot. Your domain is from negative infinity to infinity, as well as your range, because it goes on forever. For this particular case, we neither have a vertex or an inflection point, so we will write NA. We have 0 turning points. We do not have any minimum and maximum. Now, as x approaches negative infinity, that means x went that way, y went downward, so that's going to be a negative infinity. And as x goes to the right, y went up, so that would be positive infinity. Now, as you can see, this function is increasing indefinitely because I'm hiking the entire way. So it's increasing over the entire domain. That means you have no other domain left for decreasing. It is definitely a function because whatever x I have chosen, there's only one y, meaning that whatever vertical line I draw only intersect my vertical line at most one time. It is also a one-to-one function because I'm going to erase all my vertical lines. Because whatever horizontal line that I am drawing, that means one y that I'm picking out, there's only one x that's possible. Now let's try to evaluate. What if I said, okay, find f of negative 3? Well, in this case, whatever x is, y is exactly the same. So f of negative 3, y happens to be negative 3 as well. So now that we are on the absolute value function, we can make a chart again. Remember before, one of the strategies to start making, to pick values and make a table is we want to pick a value that makes the quantity equal to 0. Well, since we only have y equals absolute value of x, we can pick 0 because absolute value of 0 is 0. Then we want to pick a couple of values to the right and a few values to the left of that. An absolute value of a negative 2 is positive 2, and an absolute value of a negative 1 is positive 1, and an absolute value of 1 is 1 and 2. We have enough values. Let's plot it out. When you have negative 2, y is 2. When x is negative 1, y is 1. 0 is at 0, and it's symmetric on the right side. Now make your lines completely straight. Okay. Now this is what's called a V graph, right? So an absolute value makes a V graph. The X and Y intercept, they are exactly the same for this particular parent function. Your domain is from -infinity to infinity, aka all real numbers. Now your range, the smallest y value is 0, okay? So we will start with that because in interval notation, we will start with 0. And remember, bracket means it is inclusive. That means I do want 0 in the range, and it goes all the way to positive infinity. Now another way of writing this is y is bigger than or equal to 0 for the range. We have one vertex. It is 0, 0. It happens to be the same exact location as your x and y intercept. We have turning point wise, we have one turning point. Maximum and minimum, we have one minimum value, and the minimum is 0. The end behavior, as x is going to the left side, which is towards -infinity, y is going up, so that is towards positive infinity. As x is going to the right towards positive infinity, y is going up, so that's going to be also positive infinity. So as you can see, the end behavior here is they're both up and up. Interval, remember we talked about increasing interval is when I have to do a little bit of hiking, so I'm really hiking on the right side. Now the vertex, it's where we break off from increase and decrease normally. So increasing is from 0 to infinity because the vertex was at 0, 0. Now decreasing is when we can slide down. Whee, thumbs up, yay, okay. So decreasing is from -infinity to 0. This is definitely a function because whatever x I pick, right, oops, I erased. Whatever x we pick, there's only one y value, and so it passes your vertical line test. This is not a one-to-one because when we make one horizontal line here, so when we pick one y value, let's pick this, let me erase some more. When we pick, let's say this y value, what's happening? You have two x locations, one over here on the negative side and one over there on the positive side. So it fails your horizontal line test, so it's not a one-to-one. Now write this in, evaluate, find x when f of x is 4. So I want to look for x when y is 4. So 1, 2, 3, 4. I'm going to go up and draw a line here. As you can see, I should have two x values. One on the right side, so that's going to be a positive 4. So x equals 4. And then one's on the left. But if you look at my graph, it's a little bit off. Would you agree? Because graphing by hand is never really perfect. So what we should do is we should go and see where that is. It should be symmetric from left to right. So if I were to regraph this, it should really line up perfectly at the edge here. So that should be a -4. So x is -4, 4. So we have two answers. So when y is 4, x is at -4 and +4. So the next parent function we have is the quadratic function. Y equals f of x equal to x squared. So usually we only use y or f of x, okay? Normally we don't use both. So normally you would see y equals x squared or f of x equals x squared. But if you see f of x, usually means it is a function. Okay, so let's make a table for us. I like using 5 values because it's easier to make a curve or a straight line that way. Again, we will start with 0. When x is 0, 0 squared is 0. Then I want -1. The quantity of -1 squared class is really 1. Then we will go to -2. The quantity of -2 squared is going to be 4. Then we will pick 1 and 2. 1 squared is 1, 2 squared is 4. So we have 5 values. That's plenty to make a nice graph, okay? So at 0 is 0, 1 is 1, and then 2 is 4. Now this looks like a V curve, but it's not. So make sure you guys round out the bottom here, okay? So the bottom is not a V. So if you guys make this into a V, we will mark it wrong. So if you guys go like this, okay, so don't go like that. it's not a V. Make sure you guys round out the bottom. This is a parabola because the bottom it's rounded out, okay? So make sure you do not make it look like a V, which I'm having a hard time the second time around here. So round it out. There you go. That's much better. Okay, so x and y-intercept, they are both at the origin since we have the parent function. The domain is all real numbers, which we now write it in interval notation from negative infinity to infinity. The range is from 0 to infinity. Sorry, my garner's here. So we have one vertex, it's at the bottom, and our vertex is 0, 0. Again, it's at the origin. We have one turning point. Remember, the turning point is when it separates from the increase and the decrease, okay? We again have one minimum value, and the minimum is 0. Now, the end behavior, as x is going towards the left side, which is negative infinity, y is going up so that it's positive infinity. As x is going to the right side, which is positive infinity, y is also going up to positive infinity. So we have up and up. They're both going up towards positive infinity. We have one increasing interval. So again, we talked about the max and min being the separation about increase and decrease. So on this side is when you're hiking. So, oh my gosh, that's a really steep slope right there. So we have increase from 0 to infinity. And then over here is when we have a sliding down motion. Oops, that head is way, there you go. We on that side. So that's a decreasing from negative infinity to 0. Is it a function? Yes, it is, right? Because a function means that one x value that we make, or any x value that we make on the graph, they should only have one y, or you should only have one y. Now, those are vertical line, and again, it passes the vertical line test. Now, is it a one-to-one? No, because that first y that I made right there, it intersected two x locations, so it is not a one-to-one. Find x when f of x equals to 9, okay, equals to 9. Take a moment, find the answer, let me know what you got. Okay, so when x is 9, I don't have 9 graphed here on this, but that doesn't mean you can't find it, okay? So we can go back to the chart and add in some more values. So here's x, here's y. So when x is 3, 3 squared is 9. When x is negative 3, the quantity of negative 3 squared is also 9. So as you can see, when y is 9, x has two values, negative 3 and 3. That's why it's not a one-to-one, because there are two x values for one y value. Next, parent functions, cubic, woo woo. So it's f of x equals x to the third, or y equals x to the third. But again, let's make a table just to see what this looks like. We will pick negative 2, negative 1, 0, 1, and 2. Negative 2 to the third, that will give us a negative 8. Negative 1 to the third, that will be negative 1. 0, 1, and 8. Let's plot those. Negative 2, negative 8, negative 1, 0 stays, 1, and 8. All right, connect those dots. Okay. So we have one x-intercept again, and the same location for y-intercept. The domain is going to be from negative infinity to infinity, so it's the range. We have one inflection point, okay? The inflection point, remember, is the change in concavity. So the concavity is now opening downward, and all of a sudden it went and opened upward. So this right here is the inflection point, and it happens to be at the origin as well. So again, the inflection point is the change in concavity, okay? When it goes up to down or down to up. We do not have any turning point, so we can write 0 right here, 0 turning points. We do not have any min or maximum because it does not change from increase to decrease. So actually, let's go talk about increase and decrease. Would you agree that you're hiking up the entire time, right? That no point that you are going to be sliding down. So that's going to be increasing from negative infinity to infinity. That's why we don't have any min and max, because we didn't have a change in increase and decrease. That means it leaves decrease to NA. Now let's go and fill out the end behavior. As x is approaching negative infinity, y is also approaching negative infinity. As x is approaching the right side, y is also going upward. So we got down and up. Now, is it a function? Yes, it is. It's also a one-to-one, so that's a yes. Evaluate. I would like for you to find f of negative 4. So negative 4 to the 3rd power. Go ahead and give me the answer, please. Good job. Negative 6. And that's it, guys, for 2.5. Let's wrap it up with a joke. Here's the toddler joke of today. Why didn't the skeleton go to school? So why didn't the skeleton go to school? His heart wasn't in it. Haha, get it? Skeleton doesn't have a heart. Happy Halloween!